Good evening, my dear JEE Warriors 2026 and 2027. So let's begin the concepts of two-dimensional motion and the kinematics usage, the projectile motion, projectile from a hill, projectile from a ground, the equation of trajectory, and many PYQs along with the numericals and the application, the theory, my handwritten notes, my complete concept with the application so that you are confident by the end of the class to solve the PYQs. So with me, your Captain Shreyas, here we are. Hi Uma, hi Sankreshwaran, hi Abhijit, nice to see all of you. Hi Ramyashi, Janani, Sandeeps, welcome everyone. I hope you guys are doing great, fabulous. Yep, and I'm pretty sure in the years to come, you too will have an amazing biodata, right? You will be also putting a tag name of some IIT, maybe some triple IT, maybe IISc, maybe NIT, maybe BITS, whatever it is. And that sense of pride, that feeling that you can get through, the college degree that you have from some top tier college, that is something which nobody can explain. You have to experience it. Going to the finest colleges in the country, being in the top 1-2% of the country, and achieving something. I'm pretty sure you want to get there very soon. So stay tuned on the Vedantu J English channel, my dear warriors, and like the video, subscribe to the channel, be regular on the channel, keep watching as many videos as possible. Old videos, 1 year, 2 years, it's fine, but be consistent, right? So you will be also one of these achievers very soon, I'm pretty sure, like Daksh or Prakhar or Aryan or Sahil or Vipul or even Sabyasachi or Ketan or Anubhav, who have made us immensely proud. And 1 out of 3 Vedantu students cracked the JEE Advanced examination. That's an insanely high ratio. And All India rank 1 in ISI exam, that's also from Vedantu, right? So hello everyone, and I can see a lot of students saying hi. So I think I should also put up your names on the chat box out here. Welcome, guys, and hi Ahmed, hi Adarsh, hi Vijit, welcome, and smash that like button. Yeah, please do that. Tarun, Mahesh, welcome. So let's begin the concept of projectile motion. Now, when we talk about projectile motion, you might think about something which is thrown at an angle. That is fairly fine. But before even entering projectile motion, let's understand that it actually comes as a special category of 2 or 3 dimensional motion. See, in the previous lectures, we have seen what is a one-dimensional motion or straight line motion. That object is going along a road, or it's going and turning back, or it's just going up and coming down, or it's thrown from the up and it's going down. So along a straight line, there is no curvature, there is no circular path, square path, nothing. It's going along a straight line. So a motion in 2 dimension or 3 dimension is where the object is going in the space like an aeroplane, a bird which is flying, or a ball which is thrown in the air, or anything which is moving randomly on a curved path. And in that scenario, when you are going in a space or in a random environment, you have your position which can be determined by 3 coordinates: x, y, and z. These 3 variables will determine your position x, y, and z. So as you move, your x coordinate will change, your y coordinate will change, your z coordinate will change. As you move, your x coordinate, y coordinate, and z coordinate, all the 3 will change. Are you able to visualize this? Try to simulate this in your head. Now, imagine instead of looking at that 3 dimensional motion, somehow it is going, I only focus on the x coordinate. Then I will see the x coordinate going along the straight line. If I just focus on the y coordinate will go along a straight line. If you just focus on the z coordinate, then the z coordinate will keep changing along the z direction. So if I focus on the individual x, y, z coordinates, they all appear like one-dimensional motion. 1D motion here, 1D motion here, and 1D motion over here. Is that right, everyone? Okay. So now think, if I have already studied one-dimensional motion, and these are 3 one-dimensional motions, one in x, one in y, one in z. If I combine these three one-dimensional motion, I exactly get the particle's journey, the motion. So when I study a three-dimensional or two-dimensional motion, it's like studying two or three one-dimensional motions together separately. One in X direction, one in Y direction, one in Z direction. How many of you are able to accept this fact? Yes? No? Subha? Sana? Abhijit? Taruna? Girish? What say? Mahesh? Ahmad? Adarsh? So when you study a three-dimensional motion, it's like studying three one-dimensional motions in three different directions. So I can definitely say that a motion in three dimension is nothing but the motion in 1D along each axis x, y and z combined together, which is combined together. And we already know that the position of a particle has a symbol r. It's a vector quantity, so r bar. So the position vector of a particle will then be given by x coordinate something I cap, then there will be some y coordinate, and then there will be j cap, and then there will be z coordinate, and this will be k cap. So this is nothing but the position of the particle, and obviously this x, this y, and this z, they are the coordinates. So combining them, I basically get my three-dimensional motion. Or two-dimensional motion, I will just need any of the two coordinates. Everyone with me on this? Yes, Abhijit, I know you're very regular, and I want everyone to be regular in this series. Perfect. Okay, sir, this is fairly fine. I understand this. Can we now use this and get velocity, acceleration, and displacement and other things? Why not? Definitely we can, and we can define it also. So let's understand this one by one. If this is position, then we can easily get the displacement. How? So the displacement, S vector will be nothing but the change in the position. So the change in the position. So therefore, change in the position means it is final position minus initial position. So all you need to do is take the final coordinate, subtract it with the initial coordinate. That will be I cap. Then same thing with the y-axis coordinates, subtract the coordinates, that will be j cap. And of course, the z final minus the z initial, that will be k cap. So that will give me the displacement, which is the change in the location, which is nothing but the change in the location or the change in the position of that particular particle. If I take the displacement and divide it with velocity, divide it with time, I will get the average velocity. So the average velocity, average, average velocity, average velocity will be nothing but displacement divided by time. But in slightly better form, I can also write it as change in position, and this is time. I can also put time interval. Okay, delta t, it's one and the same thing. Time taken or time interval, one and the same thing. So usually you will see this particular equation being used. This is average velocity, a decently change, decent time and decent change in position. So that is average. But if you look for instantaneous, instantaneous velocity, then it will be just dr vector divided by dt. It will be nothing but just dr vector with dt. And when I take the derivative, you might have to take the derivative of x, y, z, or all the three components separately as well. We'll do a question so that you get an idea. Also keep in mind that when that particle will go in some three-dimensional motion or two-dimensional motion. So this is the motion of that particle, that is the path which it has taken. The velocity at any instant is always going to be tangent to the curve. That is very, very important. The velocity, right, which you show over here, that velocity is always along the tangent to the path. The velocity is always along the tangent drawn to the path. If I'm going like this, at this point, my velocity's direction will always be along the tangent. If I'm here, my velocity will be always again along that tangent at that point. That is something which you should be aware of. Let me show you some examples so that you guys get an idea. So imagine this. I tell you that initially there is a particle which is located at 0, -1, 3, and final coordinates are given as 2, 3, and 1, and it transits from here to here in 2 seconds. Question is, can you find the displacement? Also, can you find the average velocity? Can you find the displacement, and also can you find the average velocity? Let's do this. As you can see, three coordinates, three-dimensional motion problem. Initial coordinates and final coordinates are given to me. So as soon as I know initial and final coordinates, I can immediately subtract them to get the displacement. So in order to obtain the displacement, I have to take the final and subtract it with the initial. Final minus initial, each coordinate separately. This will be I cap. Here it will be 3 minus -1, but that will be j cap. And lastly, it will be nothing but 1 minus 3, and that would be k cap. Is that right? Everybody with me? Perfecto? Amazing. So what now? The displacement will be, this is nothing but 2 I cap, and this is plus 1. So it will be 4 j cap, and this will be nothing but minus 2 k cap. So 2 I cap plus 4 j cap minus 2 k cap meters will be the displacement. Simple, straightforward. Now let's go to the average velocity part. If I want to go to the average velocity part, here is what I'm going to do. I'm just going to take the displacement and I'm going to divide it by the time taken. The time taken is 2 seconds. Displacement is as it is. So 2 I cap plus 4 j cap minus 2 k cap, the whole thing divided by 2 seconds. So the average velocity vector will be, it is I cap plus 2 j cap minus k cap meters per second. That is the answer. Very good. Everyone got it correct. Very good, Adarsh. Yes, 2, 4 minus 2 and 1, 2 minus 1. Yes, awesome, awesome, awesome. That is how easy it is. If you know 1D, 3D, 2D is a cakewalk. It's a piece of cake. Similarly, imagine now, I tell you, listen, bro, the position of a particle is given by, example, t cube I cap minus t j cap plus 8 k cap meters. Can you find the velocity at in general as a function of time? Can you find that? Okay, is the question. Can you find the velocity in general as a function of time? Also, can you tell me what is the speed of the particle at t is equal to 1 second? Chumma, I have taken some random value. Can you find out the speed at that instant at 1 second? Okay. Velocity in general is as, so let me think. Velocity generic formula, instantaneous, is dr vector by dt. Okay. So I have to differentiate r. What is r? It is this whole big thing. So it is t cube I cap minus t j cap plus 8 k cap. Use the rules of derivatives. Addition or subtraction has to be treated separately. Okay. T cube. What is the derivative of t cube with respect to time? It is x raised to n formula. N comes outside and the power will reduce by 1. So 3 will come over here and t's power will be 2. But that would be, of course, I cap. Minus as it is. What is the derivative of t with respect to t? Dt by dt gone. It is just 1. So it is just going to be 1 j cap, or just I can put j cap over here. What about 8? 8 is nothing but a constant. So for those of you who want that one, I'll put that one, not an issue. And 8 is a constant, so constant's derivative is 0. So 0 k cap. So the velocity in general will be 3t square I cap minus j cap meters per second. This is 0. So if you tell me the time, I will give you the velocity at that moment. I'll give the velocity at that moment. So it's in I cap and j cap. That means it is also having some angle which it is making. Now the second part is finding the speed. Now speed instantaneously is nothing but the magnitude of the velocity. Simply, it is nothing but the magnitude of the velocity. So what is the velocity at 1 second? Well, put the value of time as 1. So it will be 3 multiplied by 1 square I cap minus j cap. So it is basically 3 I cap minus j cap. That is the velocity. So the speed will be the magnitude of that velocity. So magnitude means take that coefficient, all the components, square it and add it under the root. So this is nothing but root 10. Root 10 meters per second is the instantaneous speed at 1 second, because I put the value of time as 1 over here. Instead of t, I put it as 1. Is that right? Root of 10. That's how easy it is. So it feels, when you look at these formulas, oh my god, what is happening over here, sir? Complex formulas? Nothing. It's just taking derivative as usual. But now you are going to take derivatives of I, j and k separately. Here also displacement. You have to find displacement not just of x but also of y and z. But they are all in 3 different directions. So that's why I put the directional vector I, j, k. All right. Or else we cannot just add them. This. It's not possible because they are all in different directions. Keep that in mind. Okay. So that's how you solve this in 3-dimensional. So then you might be wondering, sir, if you have come till here, I have a feeling we can also find out acceleration, average or instantaneous. You're absolutely right. If you have found out till here velocity and everything, we can also find acceleration. So how? Imagine this: average acceleration is nothing but change in velocity divided by the time taken, which is also, you can put it as delta v by delta t. So change in velocity basically means final velocity minus initial velocity vector, whole thing by the time taken. So that is how you get average acceleration value, but you can also get instantaneous acceleration. So instantaneous acceleration will simply be dv bar by dt, rate of change of velocity, just the derivative of this. That is going to give you instantaneous acceleration. So sir, can you give me an example of this so that I get a full confidence? Why not? Here is the example. Imagine I tell you, listen man, the position is t I cap minus 3t square j cap plus t raised to 4 k cap. Can you find the acceleration at t is equal to 2 seconds is the question. Can you find the acceleration at t is equal to 2 seconds is the question. As you can see clearly over here, position is changing with time, and not just in one dimension, but in all the 3 dimensions. So it's a question on 3D. If you solve 3D, 2D, 1D, it's a cakewalk. Okay. Now, as you can see over here, to find acceleration from position, I will first need velocity. So how do you find velocity? First, take the derivative of this. So velocity is the derivative of the position. That means I have to take the derivative of t I cap minus 3t square j cap plus t raised to 4 k cap. Okay, let's do this, guys. So velocity will be, t's derivative will be 1. So 1 I cap minus 3 Okay, t square's derivative will be 2t j cap. dt by dt is 1. T square's derivative is 2t raised to 1. Okay, 3 is as it is. Plus t raised to 4 means 4 into t raised to 3 k cap. That's it. So that is your velocity as such. That is your velocity as such. Everybody with me? Clear? Okay. So velocity will be nothing but I cap minus 6t j cap plus 4t cube k cap. That's it. So I have got the velocity in terms of time. But that's not the end story. I have to stop at acceleration. So from velocity to get acceleration, I have to take the derivative of it. So we have to take the derivative of the velocity. So it will be d by dt of this whole thing over here, which is I cap minus 6t j cap plus 4t cube k cap. Okay, sir. So what is the next step? I cap, there is a constant here. Constant's derivative is 0. So 0 I cap minus 6 is as it is. T raised to 1. So dt by dt is just 1. Okay, so that is j cap plus 4 multiplied by t raised to 3's derivative. T raised to 3's derivative, 3 will come outside, t's power will become 2 instead of 3. It will reduce by 1. So 3t square, and that would be nothing but k cap. So what is my acceleration coming out to be? This is gone. So minus 6 j cap plus 12 t square k cap. But we have to find the acceleration at 2 seconds. Do not forget that. So therefore, acceleration at 2 seconds, minus 6 j cap is there. 12 is there. Instead of time, put 2. That's it. So therefore, the acceleration at 2 seconds will be minus 6 j cap plus 24. Sorry, how much is it? 2 square, which is 4. So 48 k cap meters per second square. That is the answer. Very good. Amazing. Yeah, welcome everyone. Those of you are joining in a little bit late, it's okay. You can watch the replay of the class just by sliding the pointer in case you are still having that backlog. But if you are able to understand it right from here, I would advise to continue watching it live, and whatever part you have missed, you can watch it after the session also. You're also going to get the notes in the description box. Okay. All right. So the trick of derivatives and integration is basically that position, velocity, and acceleration. If you think of it in one line, from position to velocity is derivative, velocity to acceleration is again a derivative. Going reverse is just integration, and integration is areas, derivatives is slopes. So position, velocity, and acceleration, that's what you need to know. Second thing is you should know the basic formulas of derivative, like x raised to n's derivative, sin x's derivative, cos x's, basic things, at least for physics, at least in 11th standard. Later on, you might need some substitution, some crazy chain rule and other stuff. But right now for 11th, it's good enough. And even in JEE mains, if you see, or any NEET competitive exam, they do not stress so much on the mathematical aspect, but they just need the basics of maths. Okay. But even if it comes, then you can do it in 12th. Yeah. So having said this, how about this particular question coming up on your screen? Okay, observe. Imagine there is a car moving, car moving towards the north at 60 meters per second, and it turns towards west at 80 meters per second in 10 seconds. Find average acceleration. Find average acceleration. Okay. And we have to basically find the magnitude and its direction. That is the question. So let's try to think, how do we do it? So usually we take upwards as north, left side as west, right side as east, and down as the south. Okay. So car is going upwards like this. So initial velocity is like this. So I'll put initial velocity is here, and as you can see, it is 60 meters per second. This is y-axis, so it will be 60 j cap meters per second. After some time, it is turning towards the west direction. That is what is mentioned. So this is what it is. So this is v final vector, and the speed is 80 meters per second. But as you can see, it is towards the negative x-axis, so minus 80 I cap meters per second. How many of you understood this? Why it is minus 80 I cap? Because I am just taking my standard sign convention like this. Okay, so I'm just assuming this as the x-axis, this is the y-axis. Y-axis is basically north, x-axis is basically the east direction. So that's why this is minus 80 I cap. This is nothing but plus 60 j cap. Good enough? Perfect? Awesome. Now what to do? See, question is to find average acceleration. Go back to the definition of average acceleration. It is how much the velocity changes upon the time. Time is given to you. Change in velocity is needed. Final and initial, we just have drawn it. So my problem ends there. That's it, guys. So if I want to find average acceleration, it is final minus initial velocity divided by the time taken. So as you can see, final velocity is minus 80 I cap. Okay. Initial velocity is 60 j cap. The whole thing divided by the time. Time is given to be 10 seconds. So this will be minus 8 I cap minus 6 j cap meters per second square. That is your average acceleration. That is your average acceleration, but it is in I cap and j cap. I want the magnitude of it because that's what is asked. So the magnitude of the average acceleration will be, take the components like 8 and 6, square them under the root and add them. 8 square 64, 6 square 36, 36 plus 64 is 100, 100's root is nothing but 10. So 10 meters per second square is the magnitude. This is a Pythagorean triplet also, 8, 6 and 10. Even if you don't calculate it, I mean, it should be there in your head. 4, 3, 5, 8, 6, 10, right? 12, 5, 13. All these are Pythagorean triplets. Cool. But that's not the only question. The question is also the direction. So maybe I can look at this. That will give me an idea. Minus 8 I cap means left side. Minus 6 j cap means downside. So the vector of the acceleration will be probably like this. And as you can see over here, this much part and this much part. Well, this will be 8 units, this will be 6 units. Does it make sense? Minus 8 I cap this side, minus 6 j cap downside. So it is like this. So this is how our acceleration is in this particular direction. As you can see, it is slightly towards the west and south, southern west direction, but it is not exactly southwest because southwest is exactly 45 degrees with the south or the west. I don't think it is exactly 45 because you can see the sides are not equal. We can find that angle, it's not a big deal. I mean, just imagine if I just mark this angle as theta, I can see tan theta, tan of theta is opposite by adjacent, which is 3 by 4. We already know whose tan is 3 by 4. How much is it? 37 degrees. So 37 degrees is the angle which the acceleration makes with the west direction. So the average acceleration is 10 meters per second square. 10 meters per second square. And it makes 37 degrees, 37 degrees with which direction? This is west direction, with the west direction. But if this is west, 37 degrees can be down also, can be up also. If it is here, it is on the north side. If it is here, it is on the south side, because up will be north, down will be south. So it is 37 degrees with the west, but to avoid the confusion, towards the south side, towards the south or the southern sides, towards the southern side. That is the complete description of the direction as well as the magnitude. Is this absolutely clear, my dear warriors? Is this absolutely clear? Yeah. Okay, perfecto, amazing, go. So let's march then to the next concept. So at the end of the day, 1D, 2D motion, is nothing but 3D motion is nothing but one-dimensional motion only. We have seen, okay, it is nothing but one-dimensional motion only, all clubbed together. So whether it is position, whether it is displacement, or whether it is velocity, or even whether it is acceleration, is just solving I, J, K separately. So some of you might be even wondering, is even kinematics applicable? The answer to that is yes. So even kinematic equations are applicable are applicable in 2 dimension or 3 dimension, but the condition is, what is the condition? The acceleration must be a constant. The acceleration must be a constant. So even if a particle is going in 2 dimensional, 3 dimensional motion, if the acceleration is always the same, then you can still use, maybe some initial velocity is there, maybe after some time some final velocity is there, and maybe this is some kind of displacement which is there. You can still use kinematic equations. V bar is u bar plus a bar into time. You can also use S bar is u bar t plus half a bar t square, and v square is u square plus 2 acceleration dot producted with the displacement. There is a dot product over here. Be careful, because you cannot just put two vectors side by side. It will be meaningless if they are multiplied, whether it is a scalar or a vector. As you can see, u square, v square, they are numbers without direction. They are just scalars. So you can add a scalar with a scalar only. So this is a dot product. So this is something which many people do not know. This is nothing but a dot product. Okay. So you can still use this as long as the acceleration vector is a constant. Yeah. Perfect. Awesome. Awesome. Yes, the Tattva material will have, theory and PYQs and level 1, level 2, level 3, like that. Those levels are there. Solved examples are not there to accommodate more number of PYQs and more number of questions. All right. So that is how it is. And more examples, if you want, you have the pedagogy app or even the DPPs and everything. So most of the solved examples have now been incorporated as the questions also. Okay, instead of just keeping it as solved example, it is up there as the question, and sometimes it is being taken in some higher level exercise as well, and also to give you more PYQs. All right, cool. Okay, let's see some question on this so that you guys appreciate these equations. Example, imagine if initial velocity is initial velocity is 3 I cap minus 4 j cap, final velocity is 8 I cap plus 6 j cap, and let's say the acceleration is I cap plus 2 j cap. Okay. Uh, Actually, we don't need this. And displacement is given. Chumma, I'll tell you the displacement is given. Maybe 4 I cap plus 6 j cap, something like that. The question is, can you find the final speed of the particle? Can you find the final speed of the particle? We can definitely do that. As you can see, v square will be u square plus 2a vector dot s vector. We have to find the speed, so I need u first. So let's think from here only. If this is u vector, what will be u? U is nothing but the magnitude of that vector. So it will be root of 3 square plus 4 square, which is 9 plus 16, which is 25. Root of 25 is 5. So u is nothing but 5. So I have to put 5 square over here. Acceleration and displacement will be dot producted. So I cap plus 2j cap dot product with 4 I cap plus 6 j cap. Okay. So 5 square is 25 plus 2 multiplied by I into 4i. that will be 4 plus 2j into 6j, it is nothing but 12. So 4 plus 12 is 16, 16 twos are 32. So therefore it will be nothing but 25 and 32, that is 57. So therefore the speed will be root of 57 meters per second. That is the right answer. Everybody with me? Root of 57, not 73. Just check it out. Yeah. All right. Okay. So if you are loving the lectures here, you are understanding the theory concepts here, then please continue with this series. Please continue till the end. 6 o'clock I'm coming here, 8 o'clock I'm coming here. My old lectures are there. Use that. But if you feel that, sir, I want a dedicated class schedule, I want test series and assignments, then please join the Prime batch. It is there at an affordable price. It's there down in the description box. Please check it out. Yeah, it's at a very affordable price. Please check it out. Okay. And you will get the test series, assignment, everything over there only. Okay. But obviously, I'm there on YouTube. I'm there in the Prime batches also. You'll get my recordings as well. And I am there with the most famous pro teachers as well, who are going to excellently guide you till the end. Cool. So that is the answer for this question. Now, imagine this particular question. Imagine this particular question. I tell you, listen, man, initial velocity is minus I cap minus 3j cap. Acceleration is 2I cap minus j cap. And you have to find, can you find the velocity after 2 seconds? Can you find the velocity after 2 seconds? Directly use kinematic equations. This is a 2D question. Directly use it. Acceleration is constant. That's it. You have to find velocity after 2 seconds. So V is U plus AT is our best choice of equation. Initial speed is given, acceleration is given, time is given. What else will you need? Initial velocity, just put it as it is. So minus I cap minus 3j cap. Acceleration is also given to me, which is 2I cap minus j cap. And the time is also given to me, which is 2 seconds. So it is minus I cap minus 3j cap. 2 twos are 4, so plus 4I cap. And this is just going to be minus 2j cap. Now play with i's and j's separately. Minus I plus 4j. Minus 1 plus 4 is plus 3. So this will be plus 3I cap. Minus 3 minus 2 will be minus 5j cap. So the final velocity is 3I cap minus 5j cap. That is the answer. 3I cap minus 5j cap. Be careful, guys. This was minus 3 and minus 2. Some of you thought of it as plus 2 and maybe you got it as minus j. That is not right. Okay, this is the correct answer. Cool. All right. Perfecto. Can we go ahead to the next question? Next concept. Let's go. Now, this particular question, I want you to solve as homework. Yeah, this is your homework. Easily, you will be able to do it. Homework question. And I want every one of you to post the answer in the comment section. Answer should be there in the comment section. Okay. Very simple. Displacement is given as a function of time. Magnitude and the direction will be how much. Okay. Very easy. Just like we have done the previous question. Pakka you will be getting it. The answer should be there in the comments. Even if you are watching it recorded, solution and the actual answer will be there in the PDF, which I'll be uploading it by a day or two. Okay. So even the previous session, if you see, couple of students keep answering it. So if you go to the home page, guys, you will get the entire playlist. So this is the 12th syllabus. This is the 11th syllabus. You can go to the playlist, watch all my previous classes as well. Okay, last time also we had some amazing questions in the non-uniform motion, and smash that like button. Guys, your attendance has dropped drastically. I'm not liking it. If you do that, then I'll stop taking the 11th standard class. 12th standard students are showing more enthu. Not done. If you do that, I will then take more of 12th classes and will stop the 11th standard portions. I want everybody, not just coming over here, smashing the like button and also answering the questions out there. So very good. Some of you got the answers. PDF is already there. Homework question answer 30. Got the graph. Very good. I think I had given 2 homework questions out there. Okay. And this is the prime batch I was talking about, the Sigma JEE 2026 batch, the entire 11-12 syllabus, which will be done by October, November, followed by revision. It's pure English. It's starting batch start date 31st July. And it's an entry point basically. 5,000 rupees for the prime. And this is for the combo with the Tattva modules and the flash cards, which is for revision, small cards. And these are the coaching modules, hard copy, which are delivered to your home address. It's got test series, pedagogy access, in-class doubt solving. Even in the replay, our AI helps you answer, all your doubts. So all these things are there. So it's like a comprehensive batch. You don't need anything else. Yeah, cool. So moving on now to the concept of projectile motion. Some of the examples I just put it over here. Projectile motion is nothing but motion under gravity, but maybe you're throwing it at an angle, you're throwing it, such that it is going in a curved path. So you're launching a missile, or you kick a ball, or you throw a stone, or you are throwing a plane from the backbench onto the board. All these are examples of projectile motion. Or you drop something from a moving bus, or a plane is going and it drops a bomb, or there is a monkey which throws a banana at another monkey. All these are motion under gravity, and you can see that the ball, the object, the particle is going in a curved path. So it is a projectile motion. You are throwing it. The object thrown is called as the projectile, and it is moving, so projectile motion. So in this, we can study what is the highest point going to be, how far will you be, that is the range, highest point, the range, and how much time will you be in the air. All these things we can figure out. As you can see, the stunt man over here needs these calculations. How much time I'm going to be in the air, accordingly I can do my stunts. I have to do something. How far will I land? With what speed should I go? What height will be there? If there is some obstruction, will I be able to overcome that obstruction? All these things, right? You might have seen even in cricket or even in football, they also predict how the ball might have gone if it would not have been stopped, whether it was a leg before wicket and not. All these things are calculated using cameras to detect the speed and then predict what will happen next by computer calculations. There is no human, but the computer calculates. But the computer, to understand what to calculate, there needs to be a human intervention. Somebody to feed the formula, to load the physics model into the simulation. Isn't it? Perfect. Okay. If acceleration is not constant, then I already told you, we discussed that in the beginning only. If acceleration is not constant, we have been doing it all this while. See, our acceleration was not constant. Use derivatives, calculus basically. None of these questions, acceleration was constant, even here or even here. So you have to use derivative integration concept. Okay. So that is how it goes. Now we'll be calculating couple of things, and I'll be telling you certain things, what they are named as. First is this, then this, then of course this, then this. What are these things? Okay, called. This is R, this is H. So what are they called? Let me tell you one by one. This is nothing but, oops, this is nothing but your maximum height reached, maximum height which is reached from the ground level, from the ground level. This R is called as the range of the projectile on the ground or at the ground level. So if you are throwing it from here, it might be stopped here. That is not the range. On the ground to ground, how far will that object land from the original position? This U which you see over here is nothing but your initial velocity or the velocity of projection, velocity of projection. And this theta over here is nothing but the angle of projection. This is your angle of projection. And lastly, it will land over here after some time. So that is your time of flight. How long was it in air? How long was it in air? And throughout this journey, remember one thing, the acceleration due to gravity is always downwards. So the acceleration due to gravity is always going to be downwards. It's always going to be there. It will never ever go off. That is another thing which you should keep in mind. And we ignore any air resistance, etc. So we ignore the air resistance. Ignore the air resistance over here. And there is a beautiful simulation of this on FET. So if you just go to motion, and over here somewhere projectile motion is there. Yes, this one. So this beautiful simulation is there on projectile motion. There is also a lab over here by which you can change different things. So this is a cannon which I have, and I can change the speed also. Okay, and I can throw it. As you can see, it goes and comes over here. I can throw it at a different angle. Oh my God, somewhere and all it went. It went somewhere else. Okay, I have to zoom out maybe. Oh, see, it fell over here. I can choose something else. Maybe I can reduce the speed a bit, and you can see it is going and falling over here. So all these are examples of projectile motion. As you can see in all these things, we have essentially ignored air resistance, and you can see what happens if air resistance is there. For example, I throw it like this. This is without any air resistance and it is landing somewhere over here, okay, at a distance of 23.8 meters. If I put air resistance on, okay, if I put air resistance over here, then let's see what happens exactly. You can see there is a small difference. Can you see the pink line is slightly closer because the air drag has sucked out some energy, sucked out some speed. So the distances are not the same. So there is a marginal error because the ball was small, but if you take different objects, the air resistance could be different. Like right now I've taken a cannonball, but let's say I take a football or maybe a baseball or maybe something like that, a pumpkin. Somebody has thrown a pumpkin. Pumpkin is big over here. Now, if you throw a pumpkin, oh my God, this landed near that person because the air resistance was huge. But if I ignore the air resistance, see the pumpkin will go over there and fall over there. Exactly. Instead of pumpkin, if I take a tank shell and I fire it, it will still land at the same place. This tells that acceleration due to gravity is independent of mass and the size. It doesn't matter. Even if you take a car and throw it, somebody got very angry. See, the car also will go land at the same place, irrespective of the mass. I am throwing a human also now. We threw a human, that human also will land at the same place. Full masala only over here. So it is independent of the mass. That is what you can see very, very clearly over here. Ignore the air resistance, and acceleration due to gravity is always independent of the mass. Is always independent of the mass or even the size or the shape of the object. Is this absolutely clear? You just saw a demo of this. Everybody with me? Everybody with me? Clear? Yes, perfecto. Perfecto. Now let's try and calculate all these three things because we will be needing it throughout the lecture. And before we go ahead, let me also tell you that we can find the velocity at any instant. Say for example, I tell you, listen man, I know the initial velocity and I know the angle. Can we split the velocity into two components? Of course. So one component will be like this and the other component will be like this. The horizontal component will be closer to the vector, so theta. So it will be closer means C, C means cos. So it will be U cos theta. That's the shortcut. If it is far from theta, it is a sin. You have committed a sin. So the y component will be U sine of theta. ux is u cos, uy is u sin. If you similarly ask me, what about the acceleration? I will say there is no acceleration only in the x direction, but in the y direction, it is negative g. It is negative g because downwards is negative, upwards is positive. We can say that. So, as you can see, there is no acceleration in the x direction. It clearly means since there is no acceleration in horizontal direction, in the horizontal direction, that means the horizontal velocity should remain constant. So throughout the journey, no matter where you are, the horizontal component of that velocity, which is ux, no matter where you go, no matter where you go, will always remain the same. So this velocity Vx component, the x component which is there, so the x component which is there of the velocity will always remain ux and it will always remain as u cos theta. But it is the y component which keeps changing. So the y component will slowly reduce because acceleration is down. Eventually, it will become 0 before turning back and coming down over here. So it is at this particular location at the topmost point where the vertical velocity is 0 at the top before reversing. Reason? See, first velocity was on the top, acceleration is down. So acceleration will reduce the velocity, reduce, become 0, and then it will make it turn opposite and it will increase it in the downward direction. Please note at the topmost point, net speed is not 0. Net speed is still there, which is Vx. It is minimum, but it is not 0. Is that absolutely clear, guys? This is a common misconception which many students have. Okay, so at the top, so this is basically at the top, the net speed is minimum, but it is not 0 because horizontal speed is still existing. How many of you got it? Perfecto. Yeah, it's the vertical velocity which keeps changing, and we can use Vy is uy plus ay into t to find it out, and Vy will be uy. Uy is nothing but u sine theta. Acceleration is minus g into t. So it's just usage of kinematics in order to find anything. You can use basic kinematics to find velocity, displacement, etc., whether it is in x direction or in y direction. Just keep in mind, in x direction, acceleration is not there. Okay, so speed will be constant. Only in the y direction, acceleration is there. That's why it will keep changing the velocity. Okay, so we can see the demo of this so that you are absolutely clear. So maybe we take some kind of baseball or something, and I want to know the vectors of it. And that is why I will take this example. Okay, and let's see, guys, I'll just launch it for now. It went like this and fell down over here, so it is landing over here. Okay, so let us see the velocity vector and the acceleration vector. Velocity vector and the acceleration vector. Velocity will be green, yellow will be the uh, acceleration. Velocity will be green. Okay, so if I maybe throw it now, you can see how it is going. If I put it in slow motion, it will be very clear. See how the velocity is changing direction. Acceleration is always downwards. I think there is some air resistance. I'm so sorry, guys. Let's do it again. Let's do it again without the air resistance. Let's refresh it. Okay, we don't want air resistance. Okay, let's fire it. It goes here and it has come over here. Okay, so let's see the vectors. Let's fire it. This is the velocity vector. See how it is going up and down. Now, if you look at the components, it will be very clear. See how the components are continuously changing. See how the components are continuously changing. Again, see the y component is reducing because acceleration is down. It is the x component which is always the same. Only at the topmost point, velocity in the y direction becomes 0. Is it now absolutely clear? Even I can show you the acceleration. Acceleration is the yellow one, which is always down. So it is always going to change the y direction only. Now, is it absolutely clear, everyone? Yeah? Okay. Perfect. Awesome. Awesome. Great. Great. Your other doubts, maybe I can take it up later on. Maybe put it up as a comment, guys, not in the flow of the class, because then the flow gets broken. So better put it up as comments. That's why the comment section is there for you to ask such things which are out against the flow of the class. Okay, sir. So you are saying the x velocity remains the same because there is no acceleration. It is only the y velocity which changes, and I can use kinematic equation. At the top, the y velocity is gone because it has reversed after that. And I can find y velocity at any time using simple kinematic equation. Correct. Absolutely right. So can we now figure out how much is this height, how much is this range and all of that? Why not? Let's start by finding the height first. Let's start by finding the height first, and then we'll find the range, and then we'll also find the time. In order to find the height, I will say that my y velocity at the topmost point is 0, and I'll apply everything in the y direction. In the y direction, consider the upward journey. Upward journey. And use the third kinematic equation. V square is u square plus 2 into acceleration into displacement. Final velocity is 0. So put 0 over here. Initial velocity is exactly this one, which is obviously u sine theta. So it is u square sine square theta. Acceleration, obviously we know, is downwards like this. So I'll put 2 into minus g because it is down. And the displacement in the y direction is exactly this height. So how about taking 2gh on the other side? So 2gh minus will become plus is u square sine square theta. Therefore, the height is u square sine square theta by 2g. That is the formula which you should of course remember. Very similar to u square by 2g for a 1D projectile. Remember 1D projectile u square by 2g. Here you have u square by 2g into sine square theta. That's all. Yeah, perfect. Clear? Yeah, right. So relative motion we'll be doing later on after this, not now. We have not yet completed Rainman, boat, etc. That is a relative motion. Okay, we'll be doing it later on. Next, let's figure out maybe the time for the completion, the journey. So when it reaches here, the total time which goes is t. And if you consider again the motion in y direction, if you consider the complete journey, see what happens. Let me use S is ut plus half at square. If you consider the complete journey in the y direction, again my velocity is u sine theta only. My displacement in the y direction when I come back here is 0. Not in the x, but in the y. Y goes up and comes back. So it's the same location y direction wise. So technically, my displacement is 0 in y direction. Initial velocity is u sine theta. The time taken is t. Okay. And plus half into acceleration is negative g because acceleration we know is downwards and the total time being t square. Bring it over here. So it will become gt square by 2 is u sine theta multiplied by t. T will cancel. So gt by 2, gt g multiplied by t divided by 2 is u sine theta. T and t has cancelled. So t will be 2 goes on the top into u sine theta and that g will come over here. So time is 2u sine theta divided by g. Is this clear, my dear warriors? 2u sine theta by g, very similar to 2u by g. If you throw from Relo, 2u by g was the usual answer. Now it is 2u sine theta by g. That's it. That's the difference. Okay, sir. Perfect. The last thing remaining is the range. Last thing remaining is the range. So let me also talk about the range formula. For range, now I think we will need the horizontal direction. It's in x direction. So if I consider the motion in x and consider the complete journey in this process, let me use S is ut plus half at square. In this complete journey, the displacement in the x direction is itself the range. So S is basically the range. Horizontal velocity initially is u cos theta. So why not put this as u cos theta? This time that you take to reach here, that time we just calculated it right in this slide, 2u sine theta by g. So this time is 2u sine theta by g, which is the total time to go from here to here. So just substitute that. So 2u sine theta by g. What about the acceleration? That is 0. That is very, very important, because if the total acceleration is like this, the acceleration in the x direction is 0. So you're adding something multiplied by 0. So it is 0. So don't worry about this guy. Oh, this is easy now. So the range will be 2 is there, u into u is u square, and we also have sine theta into cos theta, whole thing divided by g. This is one way of writing, or 2 sine theta cos theta is a standard formula. It is nothing but sine of the double angle of theta. So sine 2 theta by g. So that is basically your range. That is basically your range. U square sine 2 theta divide by g. Clear? Okay. Very good. Amazing. Should we remember the derivations? Of course. Should we remember the results? Of course. That is the reason why I'm doing it, irrespective of whether you are preparing for boards, competitive exam or whatever. Please remember everything. Okay. Whatever I do in the class, at least that much you should know. Let me show you the quick demo of this. Okay. Let's say I'm throwing it at 80 degrees. I change the angle and I see what happens. It's going and falling somewhere else. Wow, interesting. The range has increased, the height has reduced. I reduce the angle further to 60 degrees. See what happens. It's going even far, but obviously lower angle means height will be less. What if I make it to 45 degrees? Wow, so far it has gone. I have gone so far, right, almost beyond this point. What if I reduce the angle more? Maybe it will go far? No, it will not. It is coming even closer now. Reduce the angle, closer. So this tells that the range is maximum for 45 degrees. Kind of makes sense also, because if I want maximum range, sine should be maximum, and sine is maximum when inside angle is 90. So 2 theta should be 90. If double of the angle is 90, so the angle should be 45 degrees. Straightforward. That is why for 45 degrees, you will reach maximum possible distance. Is that right? Now, if you further analyze this, imagine I throw it at 25 degrees, it lands over here. Complementary of 25 is 65 degrees. So let me just put it at 65 degrees and see what happens. Interesting thing, it will land at the same place, heights are different. Wow, this is so cool. How about 30 degrees? 30 degrees slightly far. How about complementary of 30, which is 60? 60 degrees if I throw, it will land at exact same place where it was at 30. Let's say at 35 degrees, I throw it even farther. Complementary of that will be 55. As you can see, it is again landing at the same place. Now, the only angle left is 45. 45 is complementary is 45 itself. That is the farthest. So for complementary angles, the range is same, but 45 degrees gives you the maximum range. So this is a very important thing which you should definitely remember, guys. Okay. So I'll just put it up over here for all of you. Okay, very, very important things. So for complementary, angles, the range is same, and there is maximum range for 45 degrees, and that maximum range will be u square by g, because sine 2 theta will become 1. So u square by g will be the maximum range. Is this absolutely clear, my dear warriors? Yeah. So this is your ground, and 45 degrees maybe like this. So if you throw it at this angle, maybe it reaches really far. But for complementary angles, it will not be so much, but the range will be the same. That's how it is. Range is same for complementary angle, and the range is maximum for 45 degrees. So this was maybe 45 degrees. Cool. Till this point, height and range, height and time and range, they can all be related if you write it in terms of u. Because from range you can find speed, and from speed you can find the time. If you know the time, you can find speed, and from that speed you can again find the height. So that's how you relate, height, time and range via the speeds or via the angles. Cool. Fair enough. Yeah. So in order to make these beautiful animations, you need a physics engine, you need matrices, the knowledge of derivatives and differential equations, and a lot of things. So it is not just a simple code, it is definitely a lot of mathematics which goes, but the processors are so fast these days, even on a web browser, the animations run so nicely. Yeah. So all kudos to computer science and mathematics, you can say. Right. So let's start with some questions coming up on your screen. I've given the summary of this over here. Okay, we have done all of this. All right, cool. So let's start seeing some questions. The maximum range is 22. When it is thrown at an angle of 15 with the horizontal, what will be the range? Come on, guys. This is very straightforward. Yeah. Come on, my dear warriors. Think what is the answer for this particular question. Let's start doing it. The maximum range is given. So R max is given by u square by g, because sine 2 theta will be 1. Yeah, this is nothing but sine 2 theta, which is 1. Okay, and this value is given to be 22. So 22 is u square by g. Therefore, u square will be 22 times of g. All right, I'll just keep it on my side, and I'll think for the new time. When it is thrown at 15 degrees, so when the angle is 15 degrees, what will be the new range? So the range will be given by u square sine 2 into 15 degrees, 2 theta, divided by g. But wait a minute, u square is 22g, so put 22g over here. Sine of 2 into 15 is sine of 30 degrees, and this g is over here. G and g cancels, so 22 into sine 30 is half. So 22 into half is 11 meters. So the range will be 11 meters, which is the correct answer. Yeah, D option, perfecto. Very straightforward. That's how you can use the range formula. All right, let's see some more questions. All right, here is this. The maximum height is 64. Initial speed is half. Then what is the new maximum height? Okay, height and speed. That's what the question is all about. And it's a projectile. We know the height is u square sine square theta by 2g. So height is directly proportional to the square of the speed. So the new height by the old height ratio will be the new speed by the old speed, the whole square. So I want the new height. Okay, then the height of the projectile, maximum height reached by the projectile. Old height was 64. New speed is half the previous speed. The initial velocity is half. So the new speed is basically half the old speed. So new speed by old speed will be 1:2. Old speed was 2 times more than the the new speed. Okay, so what will be the new height? 64 goes on the top. Half square means 1 by 4. So that is 16 meters. So that means the answer is 16. Perfecto. We got it. We didn't need G, we didn't need theta, because we just had to see how it is directly related. Just a ratio and proportions, isn't it? Moving on to the next question on your screen. Two balls, same mass, same speed, at different angles. Maximum height of the first ball is 8 times higher than that of the second ball. It is 8 times higher than the second ball. T1 and T2 are the total flying times of the first and the second ball. Then the ratio of T1 and T2 is. Okay. So let's talk about it. This is the first ball, and let's say this is the. Just one second. Just keep solving once again. Okay. Let's do this question. First ball versus the second ball. They are projected at different angles. So let's assume the angles. Let's say this is theta 2. Okay. And let's say this is theta 1. Speeds are the same. Okay. Fair enough. The maximum height by the first ball is 8 times higher than the second ball. So this is basically 8 times higher as compared to the second ball. T1 and T2 are the flying times. So this is T2. The speeds are the same. Here this is T1. This has the same speed. So this is the comparison directly. So we have to find the ratio of T1 by T2. I think the best thing to do is look at the heights and then just compare them. So height reached by the second ball, is going to be u square sine square theta 2 by g. Whereas the height reached by the first ball, which is 8h, will be u square sine square theta 1 by g. Actually, it's 2g, sorry. Yeah. So just put over here, instead of h, put this value. So u square sine square theta 2 by 2g. This 8 is as it is. This h, I have taken it from here, is u square sine square theta 1 by 2g. This equation is screaming and telling us that, listen boss, if you take the second ball's height, you multiply it 8 times, you will get the height reached by the first ball. And we are using direct formulas, u square sine square theta by 2g. U square, 2g, 2g cancels. So I am just left with 8 sine square theta 2 is sine square theta 1. So take the roots on both sides. So 2 root 2 sine theta 2 is nothing but sine theta 1. Okay, fair enough. Now we don't have to stop there. We have to find the ratio of T1 by T2. So T1 by T2, think about it. Speeds are the same, angles are different, and G is also same. Time is nothing but u square, sorry, time is nothing but 2u sine theta by g. So time is directly proportional to sine theta. U and g are the same. So ratio of the times will be sine theta 1 by sine theta 2. As you can see, sine theta 1 is 2 root 2 sine theta 2. And this sine theta 2 is as it is. They both will cancel. So I'm just left with 2 root 2. So 2 root 2 is to 1, which is option C, which is cap 2 for Captain Shreyas. Perfect. Yeah, that is the right answer. So you just have to figure out the relation between the sine of the angles, and we saw that time is also proportional to sine of the angle. So easily we can find the ratio of them. So you can have sometimes combinational questions of time, height, range, etc. as well. Let's do the next question on your screen. The angle of projection of a projectile to have same range and same maximum height. Read the question carefully. It says I want the same range and the same height. So the height should be the range. Let's just use the formulas. What's the formula for height? It is u square sine square theta by 2g. What's the formula for range? It is u square sine 2 theta by g. Obviously, u square just got cancelled off. So I am just left with sine square theta. 2 goes on the top, 2 into sine 2 theta. Okay, but how do I solve this trigonometric equation? I know sine 2 theta is 2 sine theta into cos theta. One of the signs will get cancelled. So sine theta will be 2 2s are 4 times of cos theta. I can see tan over there. So definitely I can just write sine theta by cos theta is nothing but 4. Therefore, tan of theta is 4. Therefore, theta is tan inverse of 4. Tan inverse of 4, which is D option, of course. That is the right answer. Sometimes it is just pure substitution. You should not get scared what is asked. Just go with the flow. You will understand what has to be done next. Right? So that's how, guys, you should get that confidence now after solving these many questions with me. Next question on your screen. There are two objects thrown at different angles, 45 plus alpha, 45 minus alpha, with the horizontal direction, the ratio of the time of flight. I can see 45 plus alpha, 45 minus alpha are basically complementary angles. So same speed from the same point. Obviously, since they are complementary angles, since they are complementary angles, therefore the range will be the same. Range is going to be the same. If at all, it might be useful for me. I don't know. The ratio of the time of flight. Okay, ratio of the time of flight means I just have to find T1 by T2. And in general, time of flight is 2u sine theta by g. So it is directly proportional to sine of the angle. So T1 by T2 will be sine of theta 1 by sine of the second angle. What is the first angle? First angle is 45 plus alpha. Okay, 45 plus alpha. What is the second angle? It is 45 minus alpha. Okay. Sine of a plus b, I can just use my addition subtraction formulas. It's sine a cos b plus cos a sine b. That's it. Sine a sine b plus cos a sine b. Right. So whenever you have sine of a plus b, the sign is the same. It is the terms which are different. So it will be sine 45, which is 1 by root 2 into cos of alpha plus means plus only, cos of 45, which is also 1 by root 2 into sine of alpha. Same thing here. Sine of a minus b, sine a cos b minus cos a sine b. So sine 45 is again 1 by root 2 into cos of alpha. Just minus sign will come. Cos 45 is also 1 by root 2 and sine alpha will come over here. Best part, obviously 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2 gets cancelled and I'm left with cos alpha plus sine alpha. Wow, this is more of trigonometry than physics. Cos alpha minus sine alpha. Is that right? So what do I do now? Obviously divide it by cos because I can see some tan. None of the other options seem to be matching. Definitely it can't be 1. So if I divide it by cos, so what I'm doing is I'm dividing the numerator by cos of alpha, even the denominator by cos of alpha, both numerator, denominator. So I will be left with cos by cos is 1 plus sine alpha by cos alpha divided by 1 minus sine alpha by cos alpha. So sine by cos is tan, so 1 plus tan of alpha, and this is 1 minus tan of alpha. 1 plus tan and 1 minus tan, which is option number A, of course. Where is it? Option number A. I think it is not marked, but yeah, it is option number A, of course. Got it? Very good. So many of you got it right, yeah. Sometimes trigonometry. Yeah, they can put in some bit of maths out there. Yeah. So it sometimes feel like, oh, we are solving a maths paper or what, but nobody can stop NTA. NTA is like, boss, I am done. I will ask anything. Like, okay, fine, we'll do it. We have studied maths, basic maths, whatever. Now the equation of trajectory. Okay, what the hell is this? First, let me explain you what is trajectory. Then you'll understand what is equation of trajectory. Trajectory. You might have seen Bollywood, Hollywood movies. What is the trajectory of the missile? Some sci-fi adventure, some war movie. A trajectory of a missile, meaning the path of a missile. It's just a high-find name. Trajectory means path. And equation means I need an equal to symbol. But when I say equation of a path, it should not contain time. It shouldn't contain time information in it. Such a equation is called equation of trajectory. So it could be any function of x, y, and the z coordinates. That function is basically an equation of trajectory. That function is basically an equation of trajectory. Okay. So any function of x, y, and z in general without time, eliminating time, that is an equation of the trajectory. So maybe our particle is going like this. So this is the path or the trajectory, and that path or the trajectory will obviously have some x coordinate, some y coordinate, who knows, right? So it might have some y coordinate, some x coordinate, maybe some z coordinate as it moves, So a relationship between them is called as the equation of trajectory. Just to give an example, say x is t cube, let's say y is 2t. Can you find the equation of trajectory? Yes, sir. How are you going to find the equation of trajectory? Eliminate time. How to eliminate time? Okay, y is equal to 2t. So y by 2 is t. Oh, y by 2 is t, sir. So therefore, x is t cube. So instead of t, I'll put y by 2 cube. That's it. This is the equation of trajectory. If you want, you can play this around. 2 cube is 8. So 8x is equal to y cube. This is your equation of trajectory. Very laddu, very simple, very straightforward. Okay. Why no time? I'm interested in the path. I'm not interested when. So I'm interested in the equation of the path. How is the path taken? So I'm asking you, what is the path taken? I'm not asking you when is it reaching in this position. So that's why I'm not interested in the time. So equation of path. So in that path, I can go slowly, fastly, however, I want. So time does not matter. So if you ask me, what is the equation of the trajectory of a projectile? Specifically, because the equation of trajectory can be for a bird, for an aeroplane, for a monkey jumping from one tree to another tree, for an apple falling, for a missile which is launched, anything. So in that case, here is what I will do. This is my x-axis, this is my y-axis. My projectile is thrown from here at some angle. Okay, this is u, this is theta, and it will go along this particular path, maybe like this. And I'm interested in the trajectory, that means the y coordinate and the x coordinate relationship. So this is the x coordinate, this is the y coordinate at any instant, at any instant as it moves. So if you ask me what is the x coordinate, I will say it is the x displacement. It is nothing but the x displacement, and x displacement is uxt plus half ax t square. Initial speed in the x direction is nothing but u cos theta, so multiplied by time. Acceleration is 0, so this term just vanishes. So it is u cos theta multiplied by t. So therefore, time will be x divided by u cos theta. This is a very important thing. Time, we just got it as x by u cos theta, which I will use it for y. Y is nothing but the displacement in the y direction, which is nothing but initial velocity into time plus half into acceleration into time square. Therefore, y will be equal to uy, initial velocity in the y direction is u sine theta. Instead of time, put x by u cos theta, put x by u cos theta plus acceleration is negative g, time square, that means this is square, so x by u cos theta whole square. Wherever time was there, I need to eliminate it. That's the reason why I first figured out what the time in general is, so that I can substitute. That's exactly what I have done over here. I mean, I wrote what time is and then I put that value of time in this equation and I got it. So that's what I'm doing here, trying to eliminate time. Okay, so I don't need this anymore, eliminating it. So therefore, y will be equal to u and u gets cancelled, sine by cos is tan, so x tan theta minus is there, g is there, by 2 u square cos square theta is also there, and we also have x square over here. This is the equation of trajectory because this has no time, but it is a function relating only x, y, z variables. So this is the equation of trajectory. Perfect. But if you are smart enough, you can also get this in terms of range, and it looks something like this: x tan theta 1 minus x by the range, r being the range. Both of them are the same thing. If you substitute the formula for range, you will get this after opening the brackets. So please remember both the formulas, because sometimes they might ask you the range, or range might be given and you might have to solve this. Okay, so it's better to remember it. An interesting thing, although, about this particular formula is, whether you look at this or this, okay, whether you look at this formula or, yeah, this formula, is if you compare it with quadratic equation, y is equal to bx plus ax square plus c. This is a quadratic equation because square term is there. As you can see, the coefficient of the square term is negative, the constant term is 0. This means that the graph, because c is passing through 0, sorry, c is 0, it means the graph should pass through origin, number 1. Because it is a quadratic equation, it is a quadratic equation, the graph must be a curve which is called as a parabola. Parabola is a curve, and because this a is negative, that means it should be inverted parabola. Inverted parabola. A regular parabola is like this, inverted parabola is like this, which is perfectly fine. So this graph is a parabola. The path taken by a projectile motion is a parabolic path, is a parabolic path, and which is facing downwards. Inverted parabola. Sometimes people also call it downward parabola. Upward is like this, downward facing is like this. Very, very important. All right. So let's see how these questions are applied in questions. Moving on to the question coming up on your screen. The trajectory of the projectile is y is x minus x square by 20. X and y are measured in meters. The maximum height attained by the projectile will be. Now, if you look at this, suddenly you will get scared. Oh my God, equation is given and maximum height is asked. Okay, let's think carefully. Be patient. Sometimes you might not even need direct formulas. You might have to use some logic. Okay. This is a quadratic equation. As you can see, y is equal to minus x square by 20 plus x plus 0. This is a quadratic equation. Graph is passing through origin and it is inverted parabola. So 100% the trajectory will be like this. It is going to be a parabolic path or parabolic trajectory. Question is find the maximum height. Oh, we have to find the maximum height. That means this what we have to find. At this point, can you not see if I draw a tangent, at the highest point, the slope of the tangent will be a big fat 0 at the top. So how about finding the slope? The slope is dy by dx. I'm just saying that the slope will be 0 at the topmost point. The derivative of this will be minus 1 by 20 as it is into 2x plus x's derivative is 1. Constant is not there. Anyways, it will be 0. So if I take this guy on this side, it will be 2x by 20 is 1. 2 cancels, 10 is there. So x is basically 10 meters. So that means at 10 meters, the height is maximum. But question is how much is that height? That height will be the y coordinate, when x is 10. So put the value of x as 10. That's all. So instead of x, put it as 10. Okay, plus 10 over here. Therefore, height will be equal to 10 square is 100. 100 by 20 is 5. So that's it. So height will be 5 meters, which is option B, of course. Perfect. So that's how you can solve this question. Did I need the actual equation of trajectory? The answer is no. Sir, but I learned it. It's okay. Sometimes a direct question may come, but sometimes they are testing your analytical skills. How are you analyzing this as a quadratic equation? How are you solving this as a maths question? Because in basic maths, you have learned quadratic equation, everything, algebra you have learned. Oh, so are you able to apply that concept of parabola, quadratic equation, slope, derivatives? That is what they are checking. That's why it's a good question. Is that right? Everyone? Questions may not be just directly. So in this question, maximum height was asked. So I thought, if this is the equation, how will the graph look like? So I realized writing it like this, it's a quadratic equation passing through origin. Because of the negative term, it is a inverted parabola. So maximum height means from the x-axis, what's this? And speciality at that point is if I draw a tangent, the slope is 0. So how do I find the slope? Slope is derivative. So derivative of this guy. So minus 1 by 20 is a constant. A derivative of x square is 2x, correct? X's derivative is 1, 0 is 0. Okay. So if I bring this guy over here, it will become 2x by 20. This one will stay over here. 2 cancels. So it will become x by 10. So x is 10 meters. So at 10 meters, at x coordinate 10 meters, x is not maximum height. At this location, the height is maximum. So if I know the x coordinate, finding the y coordinate is a piece of cake. If I substitute 10 over here, I will get the y coordinate, which is the maximum height. Is this now clear? I've just repeated the entire procedure once more. Got my trick? Everyone? Cool? Okay? Perfect. Let's see. More questions are coming up on your screen. Don't worry. Here it comes. The y coordinate is 5x into 1 minus x. Okay, it's a quadratic equation. Can you see? How many of you saw this? It's a quadratic equation. The power of x is 2, highest power. Okay. And the initial velocity in the x direction is I cap. And the equation is given the component vector of the initial velocity is, oh my god. Okay. Let's see what and all is given in the question. So if I expand y, it will be 5x minus 5x square. This is definitely a quadratic equation. Okay. Another information is also given to me. What is that information? Initial velocity in horizontal is I cap. That means ux bar is I cap. Therefore, initial velocity in x magnitude wise is 1 meter per second. Unity. Question is, find the component vector of the initial velocity in y direction. So they have asked, what they have asked is what is the initial velocity in the y direction. That is what they have asked. What is going to come over here? Oh, so I need to find either the angle or maybe the total velocity. Somehow we can get it. How do we do it? Let's look at maybe our trajectory equation, something we might get. Oh, if I compare it with this, maybe I will get something. Maybe. Let's see what I will get if I compare it with this. Okay. So comparing it with our original quadratic equation, y is x into tan theta. Y is x into tan theta. So tan theta multiplied by x minus g by 2 u square cos square theta and x square is there. So I can compare this with this also with this. Best part, I think better to compare this angle. It will be easy. So tan theta by comparison is just 5. Can you see that, guys? Tan theta by comparison is just 5. I'm comparing these two things together. Also, this can be compared with this whole thing over here. Oh, tan theta is 5, sir. So what now? Logically speaking, this is x velocity, ux. There will be some y component of velocity. So this will be the total velocity and this will be the angle over here. And tan theta is also uy by ux. Oh, now I get it. So tan theta is also uy by ux. Oh, perfect, sir. So I want uy and ux, I just told it is 1. So therefore, uy is 5 meters per second. Is that the answer? Yes, it is the correct answer. Perfect. Job is done. See how we approach the question from somewhere and all. We compare. I didn't know whether I had to compare or not. Chumma, I thought, let's do that. And we just saw ki comparing this will be better because what will I do comparing this with this? I don't want speed, cos theta square and all of that. It's unnecessary a problem. And I realized why I should compare that also because if I know initial speed x direction, to find y direction, either I need to know theta or I need to know u. If I know u, using Pythagoras also I could have found it. But finding u is a more trickier thing because I don't know cos theta and all of that. Got it? Perfect. Amazing question. Loved it. Okay. Okay. So take it slow. Sometimes people take some time to understand the concept of trajectory and path and all of that. So take it slow. Not an issue at all. Let's go to the next question coming up on your screen. The trajectory of a projectile in vertical plane is this much. The question is, okay, horizontal and vertical distances of the projectile from the point of projection. Alpha and beta are the x and y coordinates. Okay. Okay, fine. Okay. Angle of projection is theta and the maximum height h and the angle of projection is given by. Okay. So you have to find everything, right? So y is alpha multiplied by x minus beta multiplied by x square. This is definitely a quadratic equation. I can compare it with our original equation. Y is tan theta into x minus g by 2 u square cos square theta and then you have x square. This is equation of our projectile motion. Now comparing only directly, many things will be obvious. Like I can compare this and this, x multiplied by x multiplied by, these both are equal. So therefore, tan theta is alpha. Therefore, theta is tan inverse of alpha. That's the first question which is asked. What is the angle of projection? What is the angle of projection? That is obvious now. It is tan inverse of alpha. So either it is A or B. It can't be C. It can't be D. So two options automatically got eliminated. Now let's go to the second part. we have to also find the maximum height which it has attained. Now, in order to find that out, I have an idea, guys. Again, just think, I can use derivatives. This is x-axis, this is y-axis, isn't it? This is your x, this is your y. The graph will be like this. It will be a parabola. And speciality at the top, what is it? The slope will be 0. And this is our maximum height. The slope will be 0. And what is the slope? Slope is derivative of y with respect to x. The slope has to be 0. What is the derivative of this? So derivative of alpha x minus beta x square. So 0 is equal to derivative of alpha x will be alpha multiplied by 1 minus beta into 2x. So shifting things, 2 beta x will be alpha. Therefore, x will be nothing but alpha by 2 beta. But that's not the challenge. See, if I get the value of x also, I need to find y coordinate, which is the height. So now what we are going to do to find height, we need the y coordinate. So y coordinate, use this equation. Just substitute x as alpha by 2 beta. So alpha into, instead of x, put it as alpha by 2 beta minus beta is there and x square is there. X square means alpha square by 4 beta square. Just check this out. How much is it coming out? This will be alpha square by 2 beta minus beta will cancel. So alpha square by 4 beta. Half minus 1/4 is 1/4. So therefore, the height will be alpha square by 4 beta. Alpha square by 4 beta, which is right over here. This is wrong. So B also got eliminated. So option A will be the right answer. Perfect. That's correct. So derivatives, comparisons, equation of trajectory, everything together. Is it clear? Is it getting better? Let me know, guys, in the chat box. Yes, a lot of mathematics is there, but that is how it is. Okay. You cannot expect everything should be like formula based. So give me the formula. Oh, everything is intuition based. This will be more, this will be less. I mean, then it will not be a competitive exam. And these years, papers are tougher and tougher and tougher, isn't it? Okay. Now, the last concept we'll do is the projectile from a height. So if you throw anything from a tower of a height h horizontally, then it will go and land somewhere here. And we want to figure out how far it lands and how much time it takes. But before doing that, let me remind you, imagine if somebody just drops something over here, it is just going to come down like this and hit it over here. In this process, there is acceleration in the y direction. There is no initial velocity because you are dropping. Whereas here, if you say that there is velocity in the x direction, let's say it is u, but y velocity is still going to be 0. The acceleration is still in the y direction, which is negative g, negative direction, which is negative g. And displacement from here to here in the y direction is minus h. Here also, the displacement in the y direction is minus h. From here to here, minus h. From here to here, in y direction, think about it, y-wise, I have gone negative h. Displacement is same, acceleration is same, velocity is same. So what else should be same? Obviously, the taken taken by the object which is dropped will be same as the time taken by the horizontal projectile. Time taken by the horizontal. I've thrown it from some height like this. I've gone on the top of a tower and thrown it like this, and somebody has dropped something also maybe over there. This and this, believe me, I know it is not intuitional, it is counterintuitive. But sir, this will take more time. No, sir. No, no. Irrespective of what the speed is, initial speed is the same in the y direction, acceleration, displacement are the same. So time taken by both of them should be the same. Yes, this and this should be the same. So the time taken to fall over here will be the time taken by the object to drop, which we have already calculated in the previous lectures, root of 2h by g. This is very, very important. So the time is exactly the same, whether you drop it or you throw it with whatever speed you want. Even if you throw it with very small speed, it might land here, but the time taken will be same. You throw it with even more speed, it will land here, but the time taken will still be the same. Yeah? Clear about this? Very good. So, very non-intuitive, guys. It's completely non-intuitive. So, can we find how far it lands? Can we also figure out how far does it land? Why not? We can easily figure that out because the horizontal speed which is there, this horizontal speed will never ever change. This horizontal speed Vx will be a constant. And if you ask me why, simple, acceleration is zero. So that is why the velocity will be constant. So if at all I want to find the range, if at all I want to find how far will it fall from my foot, then the range will be the displacement in the x direction, which is ux into t plus half ax into t square. Initial velocity in the x direction is u. Time taken, I just figured it out over here only, which is root of 2h by g. And this guy will be big fat 0. So therefore, it is u multiplied by root of 2h by g. That is the range. It is just horizontal speed into the total time taken, nothing else. You can use all kinematic equations. You should feel free to use any equation, first, second, third, whether in x or in y. Okay, so the range will be this much. So this is the kind of concepts which might be needed at times. So maybe we can do some questions coming up on your screen. Here it is. Let's see whether you get it. There is some kid on the edge of the cliff above the ground and throws a stone horizontally with some speed. Neglecting the resistance, the speed with which the stone hits the ground will be. Neglecting the air resistance, the speed with which the stone hits the ground will be. Okay, think. First of all, on the edge of a cliff, 10 meters above. Okay, this is 10 meters from the ground level. Okay, and you are throwing it with 5 meters per second. So this is 5 meters per second. Eventually, it is going to land over here somewhere. The speed with which the stone hits the ground, we want to figure out with what speed will it hit over here. Guess what? That speed will have two components. Yeah, one speed component will always be the same, and that is nothing but the x component. Vx will be ux, it will still be 5 meters per second. It is only the y component which slowly grows. Initial y component was 0, it slowly grows as you come over here. Oh, so the entire question is now in the y direction. The y direction, there is some acceleration also. So maybe we can use Vy square is Uy square plus 2Ay Sy. Why the third equation? Because I don't want to know the time. I already know the displacement. And this is exactly the displacement. So maybe I will take downward direction as positive for this question. So as you can see, this is the downward displacement. So the downward displacement is nothing but 10 meters. Downward displacement from here to here, downward is 10 meters, y coordinate wise, not x coordinate wise. So Vy, I do not know. Uy is 0. Acceleration is plus 10. Displacement is also 10. So this will be nothing but 200. So Vy is root 200. Okay. That's not the question. Question is to find V. So V will be root of Vx square plus Vy square. Vx, how much is Vx? It is 5. So 5 square plus Vy square, which is 200's root square, which is 200. So which will be 225. Root 225 is 15. So 15 meters per second, which is D option. Perfect. We got it. We have got it. Welcome aboard, everyone. So like I'm saying, you can use kinematics in X and Y anytime, whichever equation you want. As long as you know what's the acceleration, displacement, or you are able to predict the directions, something or the other you should know. Thoughtfully think what you will need. Always start by diagrams. Without diagrams, do not proceed. Next question coming up on your screen, and here it is. At some time, there is a truck. Acceleration is given. At t is equal to 20 seconds, the ball is released from the top of the truck. The ball strikes the ground in 1 second after the release. The velocity of the ball when it strikes the ground. Again, just like the previous question. See, imagine this truck is there and the truck's height is how much? Okay, it is not given. Something is there. And it is going like this with some speed. Sorry, acceleration, my bad. Going with some acceleration of 5 meters per second square. Obviously, the ball which is there, the ball will also have the same speed as that of the truck. But when you release it, it will stop moving with the truck. That's it. The truck will keep going in the front. The ball would have its last known horizontal velocity. So I'm moving with the truck, the ball is moving with me. And remember, the truck and the ball both are accelerating front. So when I release it, that's it. The truck will continue its journey. The last known velocity that will be there still with the ball. So the ball will continue its journey like this before it falls over here. The horizontal velocity will never change. So that ux will always be there. Ux will be ux, which will be a constant. Reason, there is no acceleration in the x direction after it is dropped. Okay, because this is after dropping. After dropping, there is no acceleration. Gravity is only going to act down. Yes, there will be y component which will be there like this. Y component which will be there like this. Are you able to visualize this? Then we'll go ahead. Are you able to visualize this? Okay. Now it is clearly mentioned the ball strikes the ground in 1 second. The velocity of the ball when it strikes the ground will be. So I know the time which it takes to fall. That time taken to fall, I think we can figure out the velocity in the y direction. V is u plus at. Yep, just think about it. So this Vy, I can say, is uy plus ay into t. Initial velocity is 0 because at this point there is no velocity in the no velocity in the y direction. It is at rest in respect to y. It is moving horizontally, that's a different story. Acceleration, it's minus 10 and time is 1 second. So y velocity is minus 10. So y component should be minus 10. Either it is D or it is A. It can't be B and it can't be C because minus 100j is there and this has no j only. So minus 10j or this one. But think about it. It also should have x component. So it can't be D because where is the x component? So it has to be A. So that is the answer. Perfect. This is how logically you should solve. X component is existing and it will definitely be there. And that is why it should be A. We can find that out. It's not a big deal. If you want to find the x component, the x component of velocity is the velocity of the truck at 20 seconds. At 20 seconds. and velocity at the truck at 20 seconds is u plus acceleration, which is 5, into the time, which is 20. So 20 into 5 is 100 meters per second. So clearly this is 100, which is exactly what we want. Okay, so x component of the velocity is also there, which will always be constant after dropping, but before that it was accelerated by the truck. So that's why the velocity of the truck is needed after 20 seconds of acceleration. So this is very, very amazing question. Yeah, cool. So I have given you already the homework question right over here. Where is it? This one. So please solve this. Answer should be there in the comment section. Cool. Please solve this. Answer should be there in the comment section. Okay. So we have done with all the questions today with the projectile motion, concept of 2D, 3D, equations of kinematics used in 2D, 3D, equation of trajectory, projectile from a hill, and all the formulas with the derivations. I hope you loved the class. If you have forgotten to like, please like, subscribe to the Vedantu J English channel. This was Captain Shreyas. Bye bye. Take care. See you again very soon. Okay.